Hello everyone and welcome to yet another recreation programming session with Mr. Azuzin. So today I decided to look into the famous couple of software called Flex and Bison. So a lot of people who wrote parsers and especially programming languages and compilers and stuff like that, they are familiar with this thing. I got reminded about this thing while doing the BC, Basic Calculator review, so you can find the link to the session in the description. And I personally don't really like to use it. I used this pair of software a couple of times when I was a student a long time ago. So my impression of it was kind of mixed up, right? It's just like you're writing in one language and now you're introducing another language into your code base just specifically for parsing, and it kind of introduces more moving parts. And any languages that I actually developed, in the past, they never really used Bison or Flex or anything like that, because I always wrote lexers and parsers myself from scratch, and it was never a problem. It was never a problem. But since I got reminded about this thing, I decided to do a session where I look at it again. Since I looked at it in the past very long time ago, I kind of forgot everything about Flex and Bison. So for me, it's going to be sort of like a new experience, hopefully, because I literally do not remember how to use any of these things. So, and maybe we're gonna just write a simple interpreter or maybe a simple compiler using these things and see if it actually improves your, productiveness as a software developer. Like, I don't really know. So as far as I know, Flex and Bison. So Flex is a lexer generator, and Bison is a parser generator, right? So, and these are two phases of basically interpretation or compilation. So essentially, what you have to do, you have to take your input, right? So let's maybe create some sort of stuff in here. So I'm going to create Flex le Bison. Okay. So, and essentially, if you have some sort of a program, right? So let's actually write a program in C. Something like that. Let's write hello world just to have something, something to work with. So the first step to analyze this program is to do a lexical analysis, which is basically split this entire program into tokens. Usually, the tokenization and processing of the pre-processing directives is kind of weird. So let's actually kind of exclude this entire thing from the equation, just to not think about it. Right, so what it does, lexical analysis, it basically splits the entire source code into tokens, into lexems. Right, so instead of like a stream of characters, now you're dealing with a stream of tokens, and usually string literal is a single token, by the way, is a single token. So this is basically what you have, and you just have a list of these tokens. And then the parser, which is supposed to understand the structure of your source code, already dealing with these sort of pre-grouped characters instead of the characters individually, right? Instead of the characters individually. So the more I think about it, actually, the more I realize that the large language models are like very similar to compilers. They're insanely similar to compilers. And both the large language models and the compilers have a tokenization step. Have you noticed that? Have you noticed that they both have tokenization step? And what's funny is that they have tokenization step literally for the same reason. Because reasoning on the level of characters is too complex and too difficult. So to simplify it for the sort of next step of processing, you need to group the characters into meaningful groups, aka tokens. It's literally the same reason as for LLMs and the compilers. So in some sense, the compilers are language models, not large language models, but language models that were handcrafted instead of trained using machine learning. This is something interesting to think about. It's something interesting to think about. And because of that, with the compilers, it's kind of easier to achieve the alignment, right? So because you literally handcrafted the entire model, right? So you formalized it like that. In case of the language models, you kind of derived the language, the model, from just the text that you gathered online. That's a stretch, bro. Fuck you. Okay, let's actually continue. So Essentially, and this is what Flex is supposed to do. This is what Flex is supposed to do, and let's actually see how we can do that. So let me bring everything back to how it was, right? So, and maybe we can try to just literally tokenize this specific program, right? So how about that? Let's just tokenize hello world in C. Right, so I'm gonna put it in like that, and so maybe I'm gonna rename it to hello. Okay, so as far as I know, I already do have Flex on my machine. And I just run it and it hangs, which indicates that it doesn't accept input from the file, it accepts the input from the standard input. Or maybe if you provide, so you can just provide the file. So I suppose if you didn't provide the file, it will just expect the input from the standard input. Okay, so it's rather interesting. So can I maybe find Flex tokenizer? So I wanna actually find what's the extension of the Flex files. So extension, does anybody know or remember the extension of the Flex files? So I remember that there was an info Flex extension file extension, almost impossible to find. Was it Y? I think it was Y, but I kind of want to confirm that from the official documentation. So there's some docs in here, as you can see. There's some docs, and it's a Flex text. So it's kind of difficult to find. So Flex file extension, Flexi texting, exactly. Flex file, Flex tokenizer file extension. Okay, so there's a geeks for geeks. I can't believe that the answer is actually on geeks for geeks. So Lex L file or Lex source program. So yeah. Okay, fuck you. I'm gonna assume that it's Y, right? So I'm gonna say Lex Y. I think it has to be Y. And I'm gonna just, okay, so this is an empty file, and I'm gonna say Flex. Oh, it's L. Okay, so let's call it L. All right, so this is gonna be Flex Lex L. All right, so impremature in the file. I don't know why, but this error message is so fucking funny. Premature end of file, holy fuck. Not just end of file, it's a premature end of file. That's what she said, exactly. That's what she said. Okay, so... oh boy. So there is an info Flex, right? And this is an info file. And I wonder if we can read something about that. So there's a little bit of an introduction. Flex is a tool. I honestly don't care. So maybe what we want to do is go into the examples. Okay, this is very cool. First, some simple examples to get the flavor of how one uses Flex, of how one flexes. Okay, so the following Flex inputs specifies a scanner, which when it encounters the string username will replace it with the user's login name. That is very interesting. So essentially, you have to put %% username and then get login. Okay, so let's actually literally try to put that stuff into our L file and see what's gonna happen. Okay, so you're supposed to put these things. Right, so what if I just try to flex it but with double %? Interesting. So the minimal Flex file is just double %, whatever that's supposed to mean. What if I put a single % in here? Unrecognized % directive premature end of file. But if you put 2% in here, it's totally fine. Okay. So, and then, so what we put in here is a username, right? So this is a username. And I suppose here we have to replace it with printf. this get logging. What is get logging, and what exactly is going on with this code? Is it going to call this code? Is going to compile this code? Is going to replace it with some? What the fuck is that supposed to mean? This is very interesting. I'm pretty sure it explains everything down below, but what I want to do, I want to literally just do something like this, right? Okay, I just called it on this file. Nothing really happened, but it created a huge ass C program, 44 kilobytes of a C program out of the 2 lines of code. Very interesting, very interesting. Let's open it up. How many? Okay, so it's a 1,737 lines of code. That is very cool. And it basically exposed a bunch of functions. This is actually kind of cool. So you have YY free, realloc, which just redirects to realloc, very important function, right? So very important function, and YY alloc, which is malloc, right? So just like wraps and you know, embeds all of these things. So YY lex destroy. So it literally generated an entire library for you. Some sort of a library, and there's a lot of functions in here, and so on and so forth. I'm interested, where is the get login? Here is the get login. Here is the text that we put in this L file. Here it is. So, which is kind of cool. So it's inside of some sort of a switch case, which is very badly formatted. So I suppose it's trying to emulate some sort of a stack machine and stuff like that. I do remember this kind of stuff in the BC source code. What I'm interested in is, what is this file? So the main scanner function, which does all the work. Very interesting, which does all the work. So, and the size of this function is 234 lines of code, right? And it's not even a function, it's actually just a macro. So I suppose we need to find this macro. So if it's not defined, oh, okay, that's very interesting. So if this one is not defined, defined is yours, and essentially they just set it to a signature. So essentially what you can do, you can just customize this signature. I'm not really sure how exactly you're supposed to use this file, but I suspect you just link with that file, or maybe just include. In our case, I think it would be easier to include this file. So let's just go ahead and maybe try to include it and try to compile it. What do you guys think? I think it's going to be a good idea. So let's create a makefile, right? So this is going to be a makefile, and I might as well actually include creating this specific file as one of the targets, as one of the steps of the compilation, right? So this is the file that we create, and this is the file it depends on, right? And then we're going to do flex, and then just like feed that file in here. So then I can just try to do make, and as you can see, it is recompiling if it's updated. Okay, so let's actually have something like main.c, right? So here's our main.c. It's going to be stdio. And let's create another hello world, right? The difference between this hello world and that hello world that I have in here is that this is basically the entry point to our interpreter or a compiler. I haven't decided what exactly we're going to be doing with Flex and Bison. Maybe interpreter. Compiler, I don't know, it's kind of tedious to do, right? So you have to translate it to a different language and stuff like that. Interpreter is a little bit easier to do, in my opinion, I think. At least for a small session that we're going to be having today. So this is a hello world, right? So, and what I want to do, I suppose let's go ahead and just include this entire file in here, right? So let's include it and see what's going to happen. Is this thing even fucking compilable? Is it even compilable? I don't fucking know. Maybe it supplies its own entry point, which I kind of doubt. Yeah, I don't think it supplies its own entry points. There is no main in here. So that means it should actually compile relatively easily, right? So it just should compile. So I don't think that particular file depends on anything. So here we're going to have main. It depends on main C, and it depends on this specific lexer in here, right? And what we're going to do in here, let's actually enable all of the warnings, all of the extra warnings. Maybe we're going to enable the debug information in case we want to step debug this entire thing, right? So let's just compile this entire thing. So I'm not going to supply this stuff, right? So because we already automatically include it in here because I want to have all of the declarations available to my main program. Okay, let's go. It didn't even fucking compile. It didn't even fucking... And rightfully so, by the way, because we don't have this stupid ass get login. So I don't really know what we're supposed to do in here. I can actually maybe implement that get login myself. Get login is going to be something like this. Let's return le login. Le login. And now, if I try to recompile the whole thing, okay, so expected semicolon got a break. Aha. So I supposed to put a semicolon here. Did they say that you have to put a semicolon in? They fucking did. I missed a I missed a semicolon. I almost spent 3 hours debugging. Okay, I'm sorry. Almost spent 3 hours debugging and it was a single missing semicolon. Okay, so does it still compile? Okay, conflicting types. Yeah, but have const char. Ooh. Ah. So get login apparently is a Unix function? I thought it's just a made-up bullshit function for... Okay, so get login, it gets the username. I literally legit thought they just made up a function for an example, and it's another... Apparently it's a Unix function, okay. So what that means, I suppose, is that maybe what I have to do is put unistd in here, right? So is that the thing I have to do? Okay, that is very interesting. So now it fails with not being able to link, right? So by the way, it also complains that I don't use some of these things, right? But now it is not being able to link because it tries to find YY wrap. And honestly, it's a good question. Why wrap? I don't know. Let's try to answer this question. So what is this function even? Right, so many tabs. Okay, YY wrap. Flag which is used to allow YY wraps to do buffer switches instead of setting up a fresh YY in. A bit of a hack. Bro, what the fuck are you even talking about? Like, what? YY wrap. Okay, so YY skip. All right, so if it's not defined YY wrap, am I supposed to define this function myself? We don't actually know whether we did this switch during end of file YY wrap processing, but the only time this flag is looked at is buffer YY wrap is called, so it's safe to go ahead and always set it. So there's no other mentioning of YY wrap except in here, and as you can see, it is actually declared as an external function, so I suppose you are expected to implement it yourself, and on top of that, this function returns integer. So that is very freaking interesting. Okay, you can do option spoilers in the chat. Spoilers in the chat. Spoilers in the chat. I'm trying to explore everything myself. It is a mystery. It is a mystery. You don't understand. You don't understand, comrade. All right, so what if I put 69 in here? What if I put 69? So is it going to compile? Okay, so yeah, that's pretty cool. So how am I supposed to use that now? So I'm supposed to probably call the function somehow, right? So, and let's find the get login. So here's the place where we do get login. And here's the YY decal, YY decal. And in YY, okay, so it's a YY lex. All right, so let's just go ahead and call YY lex, YY lex. So it also returns some sort of a value, right? So, and let's just print that value just to see what is going to happen. Right, so if I try to compile, it seems to be compiling. If I try to call this thing, is it waiting for the standard input? Really? But interestingly, it reacted to username. If I supply something like this, it just returned that. To any of these things, it just returns that. But if I supply username, it returned null. And I press Ctrl D, and it finished, and it actually exited from... I think I'm slowly starting to understand how Flex is working. Is this like an interpreter? I don't know. This is Alexa, right? So can you say that Alexa is an interpreter? But that's kind of a very philosophical question. Maybe it is. Maybe it is a kind of an interpreter, but I would say that it's a little bit of an oversimplification to call Alexa an interpreter. By that simplification, you can call any software that processes user input an interpreter. Just literally, like anything, just a form where you input an email, it's just an interpreter. It's just interpreting your email, right? So kind of an oversimplification in my opinion. But anyway, so yeah, that's kind of interesting. So is that because get login didn't return anything for me? Let's try to maybe put something like this: get login. Get login, and I'm gonna actually put maybe a new line in here just in case. All right, so let's try to recompile the whole thing. Let's try to recompile it. Is it good? Okay, so that seems to be working. And now I'm gonna put username in here. Okay, so get login literally returned nothing in our case. So that's what literally happened. It just returned nothing. But that also means that this specific thing worked. It's just called a pretty fucky-wacky function, but it worked. So absolute budgeting, I think it's a little bit of a budgeting moment, right? So, but I'm actually wonder get login. So in which case it returns null. Returns a pointer to the username when successful and null on failure with error no set to indicate the error. Okay, so that's really interesting. So we can try to maybe also do the following thing. So str error no. Right, so if I try to now recompile the whole thing and try to run this entire stuff, username, so it's successfully failed successfully. Failed successfully. I think this is a little bit of an undefined behavior kicked in because the order of execution of these functions is unknown. So it might have actually executed this function first and only then this function. Did you guys know that C compilers can do that? Do you guys know that the order of evaluation of the arguments is undefined? Did you know that? Did they teach you that in schools? We here in Russia we're taught that in elementary schools. This is like the first thing after arithmetics. This is what we're taught. Anyway, okay, let me educate you. Okay, so let's actually see. So this is going to be full, and in here this one is going to return 34, and we're going to actually put it like that. So this is going to be full, new line. And let's actually also create something like bar. So this is going to be le bar. And this one is going to be 35. And then we're going to be something like this, I suppose, right? So it's going to be printf. Let's actually print them separately to sort of simulate exactly the situation that we had. Just exactly the situation. So this is a foo, this is a bar. You would expect that it's going to be foo bar, but let's actually see what is going on in here. So foo.c, and I'm going to actually run this entire thing. So yeah, so first bar is, and don't even depend on that order, by the way. Do not depend on that, because depending on the compiler, it's going to be different. It's literally going to be different, right? So just like it's up to the compiler to reorder things to enable them to optimize things, right? So that's I think the reasoning why it's not defined. So yeah, it's kind of funny. So I wonder if you try to sum them up. So if you try to sum them up in which order they are executed, If you try to sum them up, they are executed in left and right order. What's funny is that if I just put them like that, so it's a bar foo, and it's in different order. What's funny is that, what if I enable some optimizations? It's a bar, it's still bar foo. It's still bar foo. But to be fair, if you enable optimizations, it's probably going to be computed like at compile time. But I mean, it has a side effect, so it's not necessarily going to be at compile time. But anyway, so essentially, the reason why it failed successfully is because of the undefined behavior. We depended on undefined behavior, and we got slapped in the face because of that. So I wonder how we can resolve that, because I kind of want to save the login to a variable in here, right? So I want to do something like that. But how do I have... Yeah. Okay. So Emacs automatically recognized this file as a Lisp file. And I'm struggling a little bit because of that. I wonder if I can have like a flex file, or maybe a lex file, or maybe text mode. Okay, so let's keep it like that. So what if I have something like this? Like, can I just have something like that, and then just have a little bit of a more complicated code, right? You know what I'm saying? Right, if it's equal to null, just do printf error get login, and I'm gonna put str error null like this. Otherwise, we're gonna actually say get login, and we're gonna print the login. And I have a feeling that it's not going to work that easily, because this file probably has some sort of weird syntax. Right, so let's try to recompile this entire thing. And what do we have in here? No side effect, expected semicolon. Yep, before print expected semicolon. What are you even talking about? Everything seems fine to me in here, but let's take a look at what do we have in here. So get login. Aha! I fucking knew that. So yeah, so you can only have a sequence of characters and a single line, a single statement that you can put in here, and everything below that is fucking ignored. Everything below that is fucking ignored. I suppose you have to do this nasty classical C POSIX GNU style shit, which is escape the new line to ask the preprocessor, please also consider the next line in here. Or maybe curly braces. We can try to put a curly brace in here, so that's a good idea. So I think maybe that's another thing. But I suppose if that is not going to work, we'll have to do that nasty, trick of ignore the new line. The stupidest trick in computing, honestly. I absolutely hate that. But look, if your statement can support multiple lines, just provide a multiple line support, like a proper one. Like, what is this escape new line? What is this bullshit from 70s? Like, holy fuck. In 2025, like, it should be trivial. It should be easy. But anyways, so let's actually see if it can do this kind of stuff. Okay, so that's very cool. That's very cool. So let's actually get login, and it worked. Thank you, whoever suggested that in the chat. Thank you, thank you, thank you. So you can literally just like have a piece of code in here. On encounter a particular sequence, you can actually map it to a particular code, and so on and so forth. That's pretty cool. That's pretty cool. All right. And now if I try to execute this entire thing, I provide this kind of stuff: username, no such file or directory. So that's exactly the reason of a failure for get login function. But honestly, this function is kind of beside the point of the example, so let's maybe ignore that. So, okay, so by default, any text not matched by flex scanner is copied to the output. So the net effect of the scanner is to copy its input file to the output with each occurrence of username expanded. So I suppose it is expanded to the get login. So you kind of Yeah, so it's more like a preprocessor or something like that. In this input, there's just one rule: username is the pattern. Username is the pattern, and the printf is the action. Okay, so so you have a pattern and you have an action. So the lexer maps certain patterns to actions. The $% symbol marks the beginning of the rules. Okay, so that's very interesting. Here is the another simple example. Ah, that's very cool. So essentially what you can have just regular C code, then the beginning of the rules, the end of the rules with another $%, and then you can even have, okay, that's pretty cool. And literally you don't have to do any initializations or anything like that. You can just like straight up call the yylex function, right? So which we figured out you can actually do in here. Yeah, so this is what we're doing here. That's actually kind of straightforward. I really like that. I kind of like that. So the scanner counts the number of characters and the number of lines in its input. It produces no output other than the final report on the characters and line count. The first line declares two globals. Well, I get that. I get that. So I want to try to maybe scan the input file. Right, so the hello world file, if you know what I'm talking about. Right, so this one. So we want to kind of split it into tokens. Can we split that into tokens? So, okay, how can we even do that? I suppose one thing we can do, I can just like call this thing and I can redirect hello C. And it didn't really do much, except it literally copied the whole thing into the output as the example said. So what we can try to do, we can try to maybe put an integer in here. So let's say that the integer is going to be, I don't know, integer type. So token int, right? So that's what we have in here. And now if I try to run the whole thing, might as well, by the way, include that into the make file. So this is going to be all main, and then in here we're going to say main redirect to hello.c. And I suppose hello.c is also dependent on that, but this is more of a phony target. For those who doesn't know, phony target is the one that doesn't really produce any files, right? So it doesn't do any checks on modification or anything like that, because all is non-existing files. So that's what it is. Doesn't really matter what it is. Anyways, so let's actually say, okay, so, oh, that's, fucking classic. Fucking okay. Very damn, so that's what we're dealing with. So very interesting. Very interesting. So I suppose we need some more sophisticated pattern matching in here. A little bit of a more sophisticated pattern matching. So somewhat more complicated example, right? Somewhat more. Scanner for a toy Pascal-like language. Okay, so this is interesting. So there's this thing. It's a % with curly braces needed for the call to end the file. Okay. Very interesting. So you can say, this is interesting. So you can define digits and IDs. And maybe this is what we can steal in here. So can I now put maybe something like digits, right? So this is a single digit and it's from 0 to 9. So it's from 0 to 9 and we don't even have to. Oh, and by the way, look at that. It's defined before the rules. It is defined before the rules. So can I put something like that in here? And if I try to compile the whole thing, okay, so that seems to be working. Now, if I have digits, which is multiple of them, I'm going to assume that this is basically a syntax for several digits, right? So this is a several digits. So that means I can do something like this, and I can say, okay, printf token number. Right, let's try to execute that. And all right, so here is the token number. Literally, here's the token number. So thank you so much, Redman Plus, for the sub with the message. I'm so terribly proud of sending my money to Basis for 6 months now. Also great stream. Thank you, thank you, thank you. And I'm sorry if I missed anybody else in the subs. All right, so this is how you do that. So then ID is also an interesting thing. So I think I'm going to be literally copy pasting all that stuff because it's really useful. So this is ID. Might as well even align the stuff like that. And so ID, as you can see, it's already plural in here. It is already plural in here like that. Let me see. Okay, so, oh, and you can just refer to the text in here. This is actually super cool. Okay, wait a second. So can I just do something like SYY? So it was text, right? So YY text. And then ID, so this is just an ID. Oh, and this is interesting. So look, the reason why we take it into curly braces is because if you just write it like that, what you mean it's literally the sequence I and D, right? And if you mean the variable that we defined in here, you have to put it like this. So shouldn't ID be like this? Maybe it should be like this, but I literally copy pasted it from the example, so I don't fucking know. Anyways, so let me try to do the following thing. And by the way, maybe, yeah. So since it's literally replaced in text, I might as well actually put it like that, right? So I might as well put it like that so we can sort of instantly identify it. So this is ID, and in here I can say token ID, so this is S and this is YY text. Okay, so I'm going to try to do something like that. And okay, so it identified this as a token, int as a token, and main as a token, and a lot of these things as a tokens, but it cannot really parse the string literals. So I feel like parsing a string literal is going to be kind of difficult, right? So let me, by the way, get rid of this integer. I don't think it is needed, and I think username is not really needed as well, right? So this is what we have in here. So I suppose another thing we want to be able to do, we want to be able to parse open parents, right? And I wonder if I can just do something like that, but I probably have to wrap it in quotes like this. As you can see, it probably has to be something like quotes. So, and in here, let's do something like printf token oparent, like this. I'm not going to print its text because its text is kind of obvious. Okay, so here is the oparent. It identified oparent, you know, quite effectively. You might as well put a parenthesis in here to sort of like separate everything. So, and we can do a similar thing in here, saying this is the close parent. So this is a close parent like this. So a C parent. So this is a C parent. All right, so as you can see, this is a token ID, another token ID, token oparent, token C parent, and the rest of the things. So the only problem in here is that string literals are not identified properly. Also, curly braces would have been kind of nice, right? So let's actually grab those things. I'm getting a hang of it, by the way, chat. I think I'm getting a hang of it. It's fine. I guess it is fine. So this is an open curly, right? So this is one open curly, and this is a close curly. All right, something like that. Let's go. Seems fine. Semicolons. Don't forget the semicolons. Don't forget the semicolons. Otherwise, you're gonna spend 3 hours debugging. It's the most difficult thing in programming. It's the semicolons. Semicolon. Right. So there we go. I guess that's it, right? So except string literals. String literals are probably unsolved computer science problem that we have to address somehow separately. Maybe there's some sort of like a mode switch, right? And there should be some sort of a mode switch, because even if you write in tokenizer yourself from scratch, it is usually when you encounter the beginning of the string literal, you really like literally switching the mode how you tokenize thing. It's kind of like a two separate tokenizers if you think about it. Like a one tokenizer nested in another tokenizer. So yeah, I wonder how exactly you do this kind of stuff with the flex. So since they're processing a Pascal-like syntax, right? Pascal-like syntax, they probably do process string literals, and I wonder where they do that. I didn't see string literals anywhere in here. I think they literally skipped string literals. So yeah, okay. This is the beginning of single sum, blah blah blah. Formatting the input, and that's the end of the simple example. That's the end of the simple example, and they do not address string literals. Isn't string literal just this thing? We can give it a try, honestly. We can give it a try, but I feel like it's not going to work that easily. So this is not addressing, for example, escaping. You know what I'm saying? Like escaping is not going to work like that, but we can try. We can actually try. But furthermore, like, how do you do quotes in here? Right, so do I do it like that? So this is the beginning of the quote, then something like this, and this is another quote in here. Is that how we do that? Is that how we do that? And does the order matter? Right, so let's actually give it a try. Printf token str lit. So, and then I'm gonna put YY text in here. So let's actually see if it's going to work. Okay, so I rest my case. So that's it. I don't fucking know. Yeah. Badgering. So okay, but how do I? All right, so I've got this thing. So I tokenize this entire stuff. How can I make it like ignore like anything else? Because it is printing these spaces. It is printing the spaces, and I would like it to just like do nothing if it encounters a space. And maybe that's something we can do in here. Can I just say, okay, you see space, fuck off? Can I do something like that? Or maybe even something like that. Yeah, I can say it like that. Which also means that for all of these printfs, I can say, okay, put a new line at the end of this entire thing. And that kind of worked. So furthermore, it doesn't ignore, you know, new lines. Can we say, please fuck off on spaces and new lines? I wonder if it supports this backslashes stuff. Didn't really work that well, but I wonder if I can do something like that. Ooh, 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 we tokenize this motherfucker. Badgering, absolute badgering. So that's cool actually. Damn. We can even now collect all of these things somehow, can't we? We can now even collect that. Yeah, but it doesn't really explain how exactly you like marry all of that stuff with Bison, right? It doesn't really explain that. Like, yeah, surely I can just collect things. That's true. Maybe I should bring Lenob. You guys know what I'm saying? I should bring Lenob. So tsoding nob.h. The I append, yeah. 26. I'm so sorry. Like, I'm actually working on some other projects. Like, when I get a chance, I will address all the pull requests. We're probably gonna do a new release at some point out of all of these pull requests. Don't worry about it. I'm really sorry about it. I have too many projects. And all of them are non-commercial. So doing all of them in my free time, so to speak. Okay, so let's fucking go. Nob in a makefile project. I know, right? So maybe I should migrate it to a Nob build system. I don't know. We'll see how it goes. So funnily enough, the only reason why I want to use Nob is because I need the append, right? So, which is kind of stupid, but anyways. So this is going to be nob.h, and I want to actually define nob implementation. And let me open nob.h implementation, and this is going to be strip prefix. So in here we can have le tokens. So this is going to be tokens, And I suppose this is going to be just a single token size ti count capacity. So, and the token is going to be is all of these tokens, right? So it's going to be all of these tokens, and I wonder if I can very easily and very quickly just gather them all. Can I do that? So if I just grab all of these things and I copy paste it, right, and then I try to yeah, it inserts only one, it doesn't insert all of them, unfortunately. Okay, can I do a little bit of a Emacs magic? Because I want to just like collect all of them into that enumeration. I'm gonna record the macro. Okay, so search for token, copy it, go to this buffer, new line, go back, go a little bit further, record the macro. Boom, 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 I want you in my room. Can your Vim do that? Can your... It can, I know. It can also record the macros, but it's kind of convenient. Right, so it's just basically you record an action, you repeat a couple of times, and there you go, you just collected this entire thing. Can your agentic AI do that? This is the first ever agentic AI. It's even better than agentic AI because it's predictable. Right, here's the agent. I showed my agent how to do things, and I said, repeat it n times, and it just fucking did that. It just fucking did that. Anyways, now this is a real agentic AI. I'm telling you, real agentic AI. So, and yeah, so every time we're sort of like encountering a token, we can just like append a token into some sort of a global list, right? So this is going to be tokens, and it's empty stuff in here, all right? So let's go into the Lexer, and can I also use a little bit of an Emacs magic yet again? So I'm gonna fucked it up a little bit. Chat, it's fine. Chat, calm down, chat, calm down. I'm gonna copy paste this thing. Then I'm going to do di append tokens, and I'm gonna append in this thing in here, semicolon, remove all of this shit, boom. That's it. That is it. So now we can also do what? We can just call yylex. Hopefully it's not going to print anything as standard out or anything like that. And then I don't even know what we can do in here. So maybe we can look into the list of tokens in the debugger. Right, so let's go ahead and do that. So I'm gonna put a basically breakpoint in here. Honestly, this is my favorite way to put a breakpoint. So let's just try to maybe specifically build main, right? Specifically build main, and then I'm gonna do gf2 main. But you also have to redirect this entire thing to. Damn, it's not going to work that easily. How can I call a program from GDB while redirecting? Does anybody know if GDB just supports something like this? Do you guys know? But in any case, I just run it, and if I take a look at the tokens, oh, it does support that. Oh, did you guys know that in GDB you can literally do run in it? That's pretty cool. Okay, so we can also take a look at the all of the tokens in here. So this is going to be items. I'm going to actually dereference this entire thing. So this is going to be the tokens, and let's take a look at the count. Here they are. We collected all of the tokens. I suppose I understand how this tokenizer works, like roughly, more or less. I don't know all of the details of this tokenizer. But I kind of get the main gist of it. So the only thing like I'm really curious about is like how do you redirect to a different file, right? So how do you make it read from a different file? Like on the level of redirection, it's kind of stupid to work with this thing on the level of redirection. So I don't really know. So if we take a look at this kind of thing, so format, parents, matching, generated scanner, start condition, end of file. So there's a yak, and yak I suppose is so one of the main uses for yak is a common yak parser generator. Okay, whatever. All right, I think we familiarized ourselves with this fascinating piece of technology. I think we did. You know what that means, chat? That means we have to move on to le bison. Like, how do you, make them together? Yak is bison. Okay, I get it. Cool, cool. All right, so do I have a bison? So let me see. Le bison. I do have a bison. So, and the first thing it asks for an operator. All right, so le bison. So it accepts a file. Okay, so what's the extension for le bison? I suppose it's Y, right? So it's Y. Yak. So I wonder if yak even exists here. Anyway, so I suppose it is Y. So let's actually call it parse Y. It's going to be an empty file, right? So this is going to be an empty file, and I'm going to just do bison parse. So this is an empty file test, parse.y, unexpected, finally, not some premature EOF, unexpected end of file. That's much better already. That's much better. Unexpected end of file. I don't know what else to put in here. Let's put some garbage. So unexpected identifier. Interesting. How about your mom? Okay. Nothing else to say. So let's actually take a look at documentation. So documentation for le bison. All right. So with one web page per node. Okay, let's actually take a look at this one. Oof. Oof. All right. So the concepts of Bison, languages and context-free grammars from formal rules, Bison impulse, okay, examples. This one is interesting. Now we show and explain several sample programs written using Bison, a reverse Polish notation, le curva, calculator and algebraic infix notation, so reverse Polish notation calculator. Okay, so let's take a look at that. RP calculator. Aha. Interesting. So, oh, this is, I suppose this is Lexa. Right. So here's the C and Bison declarations for the reverse Polish notation, as in C comments are placed between blah, blah, blah. So I'm not sure which one is that. Grammar rules and actions follow. This example sucks. What the fuck am I even looking at? Can you just give me a full fucking... Is this one of these things? Is this one of these stupid documentations that feed you chunks of code out of the context with the walls of text in between, completely depriving you from a full context example? Is one of those things? Is who fuck, like, there's a special place in hell for people who write documentation like that. I swear to God, there's a special place in hell. Who the fuck does that? Fuck you. Okay, so it's like, seriously, like, why people do that? Like, why people do it? It's not use. You spend time writing this documentation and it's useless. Every doc, no, some docs are actually kind of fine. Some docs are actually kind of fine. Just give me a full example and just shut up. Shut up. Anyways, so we need some, I don't even know, so something like Hello World-ish. Exercises, what the fuck is that? Are you a textbook or documentation? I don't fucking know. So how can we approach that? Maybe I'm going to go to BC. You know what? I think it's kind of an interesting idea to literally go to BC. So this is a basic calculator. The session where we explore BC is going to be in the description. So let's actually find the source code of the parser in here. So here it is. So BCY. BCY. So, and I suppose this is basically the C code. This is basically the C code. And then we do start program. So there's something like start in here, and there's a union in here. Aha. Very interesting. So it has a token, right? So it has a sort of like a token, a notion of a token. So, and a program is probably one of the identifiers that exist in here. Aha. And so this is where you sort of like start doing thing. Okay, so can I maybe create some stuff? So if I go to parse YAML, so this is what we have. Can I just put, I don't know, include math.h? Right, and then I'm going to feed it into the Bison. So this is not how you do that. Unexpected end of file. So you can't just have some bullshit in here. Okay, so let's say start program, unexpected end of file. Does it have to end in a certain way? Ah, okay. Still unexpected end of file. Okay, so Bison RPC calc, full example. RPC calc. Where can I download it? Is it even possible to just download this entire thing? RPC calc example download. Maybe I could find here. Oh my god, it is available. Holy shit, it is. Okay. So that means we're rolling. So RPC calc test. So it's just a test, but okay. Where is it though? There's make files in here. So it's a bunch of C's and stuff like that. But where is the code itself? This is useless. Where is the code itself? I didn't see it. RPC calc. All right. If I go a little bit further, man, I'm so annoyed. Did he just remove the actual part? Probably. I don't fucking know. So what am I even looking at? So Bison, can I download maybe the source code of this entire thing? Let's go into the FTP. Let's go into FTP. I'm getting annoyed, honestly. I'm getting annoyed. I kind of want to make a small break, chat. The Bison files are basically the same as Flex. Cool. I wish documentation told me literally that, and also gave just a full example that I could play with. That would have been fucking perfect. Anyways, so let's make a small break. After the small break, I'm gonna make a cup of tea and right, so we're gonna continue. We are back. Okay, so I come down, right? So I'm not tilted anymore. Kappa. Let's try to approach this documentation one more time. Let's give it a chance. Okay. So should we start with introduction? Shit, I don't want. Bison is a general-purpose parser generator that converts an annotated context-free grammar into deterministic LR or generalized LR GLR parser employing LR1 parsing tables. Once you are proficient with Bison, you can use it to develop a wide range of language parsers, from those used in simple desk calculators to complex programming languages. Bison is upward compatible with Yuk. All properly written Yuk grammars ought to work with Bison with no change. Anyone familiar with Yuk should be able to use Bison with little trouble. That's a very interesting thing. So Yuk documentation. Can you just find Yuk documentation? So this is not that. Fuck. We do need this thing. Yet another compiler is a tool used to generate parsers. This document is a tutorial to use Yuk to. Maybe we should just read the Yuk documentation. What do you guys think? Okay. So is used to generate parsers. The document is tutorial for the use of Yak to generate a parser of expl. Yak translates a context-free grammar, translates a given context-free grammar specifications input in input Y into a C implementation of a corresponding push-down automaton. A push-down automaton. A finite state machine with a stack. Okay, so it's a program. I mean, isn't program basically finite state machine with a stack? Isn't it? So it translates it to a program. So this C program, when compiled, yields an executable. Here's the thing. Like all of these people who are working on the parsers and stuff like that, it's just like, we made a tool that compiles your context-free grammar into a finite state machine with a stack. Motherfuckers, you know what else a finite state machine with a stack? A fucking CPU. Can you just write a program? It's just like, what? Why do you need to compile it to some virtual machine if you can just like write it for a real machine? It's just like, are you okay, guys? It's literally a C program, exactly. This C program, when compiled, yields an executable parser. Okay, so this is a Yak, C compiler, blah, blah, blah. So the source seal is fed as the input to the generated parser. The parser checks whether the program satisfies the syntax specification given the input Y file. Yak was developed by Steven Johnson at Bell Labs. Okay. So a parser is a program that checks whether its input, viewed as a stream of tokens, meets the given grammar specification. The syntax of seal. What is seal? Source seal. Did they even say what is seal, by the way? Did they ever mention what is seal? I don't fucking know. So okay, can we just, okay, all right. So can I get this thing and just put it in here? Is that something I can do? Is that something I can do to just, yeah. So unexpected identifier, right? So this is a start, but it doesn't, yeah, YY parse, is a structure of Yak program. It's the same shit, doesn't matter. Okay, so this is the full example, I suppose. So, and what's the name of this file? Okay, so this is just Y. All right. So auxiliary declarations, Yak declaration section. Okay, so you have a token digit. All right. A token digit. Very cool. So here is the token digit. Here is the token digit. Cool. So, and this is, I suppose, association, like a left association and so on and so forth, right? So let's actually put something like left, and this one is going to be plus, this is going to be plus, and this is going to be multiplication, right? So all of that is left associated. Here are the rules. And, okay, so, and you put that between these things, I suppose, you put them between these things. An auxiliary function section, YYR, YYLex. And here is the thing. I suppose YYLex is something that is called by the generated parser. Okay, I think this might be actually a compilable thing. Oh, seal is a simple integer language. Wait. Simple into, no, they don't say that. So seal, yeah, I don't know, whatever. Like, I don't think they mentioned it, but whatever, it doesn't matter. Waste of time. Okay, so what do we have? Parse tab.c. Finally, we got something working. Does it call YYLex? Does it ever call? Yeah, it does in fact call YYLex. Right, so which is kind of cool. So that's what we have. And so it has also YYParse. YYLex and YYParse. So, and in here, let's give it a try. I'm going to maybe include, what is that? Parse tab.c. And maybe we have to also include this whole thing. We also have to include this whole thing in here, so it depends on parse Y. I also have a feeling that You can maybe combine both the lexer and the parser together, right? So, but I'm not gonna try to do it right now. Okay, so and this thing also depends on that stuff. Let's not put that stuff in here. Okay, so can I compile the whole thing? So I cannot compile, which is interesting. So undeclared, a pause is undeclared. Pause. Fascinating. Pause is undeclared, and I suppose they declared that pause somewhere. Yeah, there it is. Here is the pause. So it's sort of like a global variable. We have a luxury actually defining it outside because we're including all of these things, right? So that means we literally can just define pause in here. We're defining it in here. So implicit declaration of function y error, did you mean error? No, this is not what I meant. And it's available in here. So I suppose y error is probably something, yeah, there you go. It's something that you defined yourself, right? It is something that you defined yourself. And we can put it maybe somewhere here. So, and who uses default integer return or whatever? So let's keep it like that. Or maybe it has to, yeah, I'm not quite sure. So conflicting types, previous implicit declaration with, so implicit declaration, did you, no. Types for have void. Was it ever forward declared? Was y error ever forward declared? I didn't think it was ever forward declared. I didn't see it being forward declared. I don't like that it depends on this implicit return thing. It's kind of annoying. And it doesn't even help. So I suppose maybe what we have to do, we have to put it somewhere here at the top, right? Returns type defaults to int. Yeah, so, and because of this kind of stuff, so can I just do voids? Finally, Jesus. Oh boy, all right. So, and then I suppose what we have to do, we have to call parse. Yeah, so that's sort of like an entry point to the whole thing. This is sort of like an entry point to the whole thing. And instead of calling lex, we have to do parse. All right. So lex and parse. But it still doesn't answer how you tie all of these things together, except this example is very cool, by the way. I think this example deserves to be put in the description because it's kind of helping me a little bit. It's kind of helping me. They don't use flex. They implement their own tokenizer. Look at that. This is kind of cool. So that means what we have to do, we have to define a bunch of tokens. In the parser, and in Alexa we have to be returning them from the lex, but the lex is rather weird. Lex is rather weird because how do I return out of lex? I think the topic of Alexa is under explorers. Yeah, lex returns an integer. It returns an integer for a reason. So the way we used it is it never returned anything. It sort of like replaced everything in one go. I have a feeling that somewhere in the tokenizer, what we have to do, we have to assign it to a variable or do some sort of a return so that lex returns an integer. Then lex function forms a convention that Yak and Bison following by constantly calling lex to pull the tokens. So the topic of Alexa is underexplored. I'm telling you, the topic of Alexa is underexplored and we're not using it correctly yet. We're not even using it correctly yet. Let me take a look at, so where is the lex L? This is definitely not what we have to do. This is definitely not what we have to do. Isn't the integer the token itself? Well, Sherlock, you're right. Yes, this is not the question I'm asking. So the question is like, how do we technically make it return things? So in a simple example, they never really explained that to you, as you can see, because they never really returned anything. So this example, even though it is simple, it is practically useless. It is practically useless. So what we want to have is, I remember that there was some sort of like a magical variable or something like that. We can take a look at BC, and in BC we had something like L. Okay, so here is a scan L, and for different tokens in here, man, I wish it was less painful to read this piece of shit. Okay, look at this shit. Look at it. This is what I was talking about. This is what I was talking about. You literally return shit. So, and okay, so if you have something like define, so where define is coming from? Ah, and that define is actually generated by the parser. So token define, it was actually like define. Yes. So, all right, I think I'm finally understanding how you bring all of these things together. So you have a bunch of tokens, and you literally define those tokens like so. So let's actually get rid of all of that shit. It's useless. So Lex L. What are the tokens? What are the tokens? The tokens are this. Here are the tokens that we are dealing with. In the parser, what do? We define them, literally defining them like so. I might as well even do something like this. Boom, we don't need a digit in here. The thing about this stuff, right, so this is the parser, this is the Bison, this is the yuck thing. I hate that. I need to provide some rules at least. This is annoying. Can I just have a empty rule start or some? Can I just have empty something, bro? You're wasting my time. Okay. Just I want an empty thing. Thank you, because I want to focus on a very specific thing. So thank you so much. Right. So when you do this kind of stuff, it probably generates defines for each and every thing. So do we have a number? There we go. So it generates the enumeration for you. Remember, I created enumeration in the main program like this. Well, it is responsibility of Bison to generate enumeration for the flex. Why people are like, why language and parsing people are like that? Why? So yeah, so this is how you integrate. So it generates this enumeration for you. The enumeration that we crafted manually, you have to use Bison to generate that enumeration, and it generates it for you by through these token directives. Verstehen? Okay. So let's take a look at like how we use them now. And essentially now what I have to do, I have to return them, right? So I literally have to return them, I suppose, if I encounter it. So scan L, right? So there was a define, yeah. So, and that's how we do that. Now I can grab all of these things. And I just say, okay, return. Just literally return, straight up return. And we might as well actually maybe remove all of these things. So all that stuff. Okay. So now if I do flex LXL, it worked. I look at the flex generated stuff. Okay, every time we encounter one of these tokens, right, so we just return one of them. And in the main, I won't be able to compile the whole program, by the way. So as of right now, I won't be able to compile this whole program. Guess why? Guess why? Oh, I was able to compile the whole program. But what if I remove? So the reason why I thought I won't be able to compile the whole program is because I never include parse tab, where all of the enumerations are defined. But isn't Lex taking the definition from the enums? Which one? Okay. This is what I'm talking about. Token and declare. Ah, yeah. So yeah, you're right. So this is what we have to do. We have to remove this one. Like, my brain thought that I removed the token thing, right? So it's just like, maybe we can realign this entire stuff. All right. So, and it should complain now. Number is undeclared. This is perfect. So, and it complains about number undeclared because it is using mapping. It is using mapping. You have to look at this thing. Right. Number. Yeah. So essentially, actual compilation error happens in a generated C file, but the compiler, since it's source mapped like that, maps it to here. Right. And so we're using enumerations that are generated by Bison, but we're not including Bison. So we have to include it, and only then it will pick them up. It will pick them up. But now Bison is complaining because we don't have YYLex for some reason. Implicit declaration of YYLex. And this is because YYLex is defined in here. So this file provides enumeration for this file, and this file provides a lex function for this file. And people who designed that think this is smart and impressive. This is smart and impressive and a PhD worthy topic. So shit that anybody can craft in their basement just like from scratch. It's not a rocket science. Why they're doing it like that? And what we have to do to actually resolve that, obviously, is just like YYLex. Where is there a forward declaration for YYLex? There's not even a forward declaration for YYLex. YYLex. That's weird. I remember there was some. Ah, here it is. Okay, and I might as well even use something in here. I can use this stuff like this, probably. Does it complain? Implicit declaration of YYLex, and it still complains. That is bizarre. Didn't I say, okay, YYLex void. Can you just, yeah, so I had to do that, like, because this macro is, yeah, so you literally have to resolve this circular dependency by literally declaring it like that. I still don't understand what the fuck is YYWrap, by the way. But it has to be kind of in here. But maybe Bison provides that. No, Bison doesn't provide YYWrap. It still have to be here. Okay. So this is how you marry these two pieces of software together. This is how you marry them. One provides enumeration, another one provides the lexing function. You have to resolve the circular dependency by doing this forward declaration, and you're Gucci. Okay, so let's try to parse this thing now. And nothing really happens, which is understandable. Okay. So we have a bunch of tokens. Let's see what we can do in here. So parse y. And I suppose we want to parse the main, right? So it's trying to parse the main. And the main effectively consists of the ID, open parent, close parent, cparent, right? Cparent, and yeah, so where is the hello? Hello. So here it is. ID, open parent, close parent, then open curly, some sort of a body, and you know, close curly, something like that. So we can try to compile the whole thing. So is it going to say cparent is used but is not defined as a token? But I mean, oh, C cparent, just like extra C. Okay. Body is used but not defined as a token or as a rule. Okay. So what is a body? It's a bunch of statements separated by a semicolon, but then don't really know how to, you know, define them properly. So if I do Y, so BCY. So let's take a look at some of the examples that we may have in here. So here's a statement list. So here's the statement. It's oh yeah. So it's you basically select. All right. So but is there a statement list? Either empty, in that case you return nothing. Statement or error. Okay, so I see how it goes. So it's a statement list semicolon statement. Okay, so we can kind of employ a similar technique. Statement. So in that case, I suppose we need to do something like STMT list. You use recursion in this kind of BNF. Thank you, Sherlock. Anyways, statement list. So, and we have like an empty situation in here, right? So we have an empty situation. Empty situation. And yeah, so this one is very interesting. So what do you do? Like, what does that mean? What does that mean? So I forgot how ugly that shit is. It is. That's how ugly it is. So and then so the statement list and statement, something like that, right? And it's like you do that with a bar or whatever. So STMT list, and this is STMT, right? So that's how we're going to be operating. And I feel like for the semicolon, we'll have to actually have a token, and we do have a token for the semicolon, by the way. So the semicolon, so that's the semicolon. And yeah, let me see how we're statement is used but not defined. Perfect. Okay, so this is very cool. So statement is, it can be a function call. We actually have two statements in here. So hello.c. So here's the first one. It's a function call, and it's going to be ID all parent str lit. I think it's str lit close parent c parent. So that's the first statement. We have to do something with it. Text mode, please. So I didn't really know what this thing does, but I suppose it just like stops, or maybe it like returns a value out of that. So then what we can do in here is what is that? ID and number, and we have to do something like this in here. Can I now compile the whole thing? And it compiles. Fascinating. So what we have to do, I don't freaking know. We have to maybe print some stuff, or like we have to be able to access some of these things. BCY, yeah. So you have an access to like one and so forth. Yeah, and I wonder what this thing does. Does it give you like a value or what? What can we do with that? We can try to print it as a string. So in here, I'm going to try to assume. So how can I format the code? I can literally just put it like that. So this is going to be like this, and let's put it like this. So printf, we're going to call it fun call, and I'm going to put it, I'm going to just assume that it's a string. I still don't understand what the fuck all that means, right? But it doesn't really matter. Doesn't really matter. Okay, so this is that, and this is that. So this is a fun call, and this is like a return, probably. So let's see if this thing is even compilable. Bison parse, it is compilable, so it is a valid grammar. We can take a look at like what exactly it generated. So fun call, all right. So it's a y value, okay. And I suppose it's just like, we can use that to sort of like immediately interpret all of that stuff, right? And let's try to now compile the final full thing, the whole compiler, and see if it's going to work. It compiled, surprisingly. So YYS type, aka integer. This one is interesting. So we got an integer. So this one is not what I think it is. All right, so that's very interesting. So let's make it an integer then. Let's make it an integer. And yeah, at least it now kind of works. Okay, so if I try to run the whole program, it waits for the input. Understandable, understandable, understandable. So now I can feed a hello C into that. YYR syntax error. Very cool. So it's a syntactical error. Syntactical error. I wonder what exactly is going on. So maybe this is not how you do the recursion. I feel like the problem here is that I copy-pasted too much from the BC, and I feel like I have to do it like that. Like, I'm not really sure why BC grammar kind of processes the statement lists in the opposite order, if you know what I mean. Right, so I'm not really sure why they do that in a kind of this opposite order, but this is not what I want. This is not what I want. All right, so, and what if we try to do the other thing? So we're gonna say that statement is statement ends with semicolon and then another statement list, which can be also empty in here, which also can be empty. And funnily enough, like I also probably have to process the whole thing, right? So I probably have to process it like that. I wish there was like a nice mode in here, right? So maybe yak mode. Nah, XML yak mode. Nah, it's not gonna work. Let's go with the text. All right, so let me try to do the Bison. Seems to be working. Let's rebuild the whole thing. Doesn't like that. Finally, expected semicolon. Oh yeah, that's understandable. Okay. Spend 3 hours. Dub. So, and all of them are zeros. Have you noticed that? All of them are zeros. If I put 34 and 35, right, so, and if I try to run the whole thing, okay, so this is not. What if I put, let's put this as a 0, and this is 34, and this is 35. Let's recompile the whole thing. I'm not really sure what these numbers are. Not really sure what these numbers are. But in this example, how do we even use them? So there's this. Yeah. One other thing I want to be able to do, I want to be able to, for example, grab an identifier. You know what I mean? So essentially, I call the function. This is obviously a function call. can I grab this specific ID? How can I get it? That's the real question I have in here. So maybe there are some examples in here that would allow us to do that. So I remember there was some function calls and whatnot. So let me see. Function call. Fun call? Does anybody remember how it was called? I think it was, yeah, this is something like, so this is an if expression. This is an if expression. Okay, so here is the, okay, so this one is interesting. So here is the name. And if you are defining a new name, check parameters, call function, look up function definition. Function definition, and it's not even defined, so it's a third. Okay, 1, 2, 3. So this is literally 1, 2, 3, but this is 1. This is actually 1, so that means I should be able to process it as a string and see it. So even though it's just like it says and it's an integer, but it's still null. It's not what I think it is. So in this example, maybe I have to put 3. Let's put 3 in there then. Well, there should be something to grab that stupid name. Okay, so name, is the name something special? Okay, so S, and I also put F in here. Oh, it's me who put F in here, I'm sorry. S value. So I suppose this is types. Okay. So this is an S value. So that means now, if I try to build the whole thing, all right, so a statement it has no declared value. Fascinating. Why me adding S in here all of a sudden invalidated the code? So because ID is a token. Now, okay, let's not maybe set anything in here, right? So maybe this is something that I shouldn't do. Like, because I don't really know what the fuck is all of that. So now if I try to compile the whole thing, unknown type, why? Jesus Christ, bro. That broke everything. And I just put S value in here and it just fucking broke every. Is S value something specific to BC calcul? Why is it here? What is, why to be able to specify the type of the token, it has to be in some sort of a union. What the fuck am I even looking at? Like, holy shit. Okay, so, but I don't want, like, I only want like this, right? So we only have integers and S values. Is it not possible to just say, okay, give me the string representation of that part of the rule? Isn't that supposed to be like a whole framework for generating parsers? And being able to say, okay, give me string of that part of the rule is a natural thing to have in a framework for parsing. Why I can't just do that? So I'm forced to do some weird ass shit. And union? What? This is not the number, but I'm gonna put it in here. Okay, that worked. And now it complains. It just works. But why exactly that? Why exactly does it have to be like that? And it didn't even work, so it doesn't matter. For fuck's sake. Yeah, I literally... What the fuck is this? It is so bad. It's the worst thing I've ever seen. And I'm saying that from a position of a person who wrote several languages. I wrote several programming languages myself without using any Bison or Yak or anything. I just wrote Lexa and a Parser myself from scratch. Okay, so I wrote, well, we wrote, right, but I was a main architect of a B language, right, this one. Right, I wrote this thing. So just, I'm gonna give you my credentials. So that's one thing I wrote. I was the main architect. A lot of people actually contributed to this thing. I'm also very heavily known as the creator of the port, right? So you can find the source code in here. So it's the port self-hosted compiler, stack-based self-hosted compiler. And off the top of my head, another programming language that I can think of is Tula, but I actually write way more programming languages, different kinds of programming languages, and so on and so forth. So I think there was also Nock, right? So simple expression transformer that is not coq, right? So this kind of thing. I wrote a lot of things. I wrote a lot of cool things, actually, believe it or not. And from a position of a person who wrote all of these things, I'm saying this is trash. I'm sorry, this is trash. Like, what the fuck is that? Like, why do you think it is impressive or smart to do shit like that? I don't think Ken Thompson didn't had Lex and Yak to make B. Yeah, I don't think he used any of that as well. Another one, Huya, exactly. So, good training language. It's a programming language that is fully Cyrillic, right? It's a fully Cyrillic programming language. And no, it is not, haha, I changed preprocessor name. No. It's a full-fledged programming language that is Cyrillic, straight up Cyrillic. It's with its own syntax and it translates to assembly. I wrote this thing. Again, from the position of like person who wrote all of that stuff, this is trash, straight up trash. And I do understand why a lot of people who professional write compilers and languages, they just try to avoid all of that stuff. It's just like, nah. It's not worth it. It's just like easier to write all of that from scratch. Like, why do I have to do that? I don't quite understand it. But interestingly, I kind of achieved an ability to just detect several statements, right? So as you can see, here is the two statements that we have in here. And at any point, I can actually maybe go ahead and in hello, add another one, and it's probably gonna be reflected like this, right? So Ken had TMG or what it was called. It's similar to Yak. What's interesting is that the B compiler that we compiled with our B compiler, right? So we actually found some historical B compiler and we compiled it with our B compiler. That B compiler didn't use any third-party dependencies. It was actually self-contained. But as far as I know, it was not really written by Ken Thompson himself anyway, so it was kind of a recreation of the compiler. But yeah, I don't know. I don't know. So yeah. So what's the goal, chat? What's the goal? The goal is to print the name of the function, right? To print the name of the function, and it's kind of an unsolved computer science problem. It's kind of an unsolved computer science problem unless we maybe read a little bit more examples. So here we never really have to. So for example here, so there is a pause, right? So there is this pause, and this is how they get the value of that thing. But then how do they set the pause? The variable to keep track of the position of the number in the input. Okay. And it's just the position in the input, but not the number itself. Mm-hmm. And this entire thing doesn't really compute anything on its own. You know what I just realized? Do I have to set some global variables in Alexa too? No, it can't be it. Because you may have several of them, and it's unclear which one. No, it can't be true. So scan L. So there's some other things we may have. So BCY. What tokens do we have? What interesting tokens do we have? Do you have something like an identifier or a name or whatnot? Yeah, we do have a name. So here's the token name. Uh-huh. Mm-hmm. You have a notion of YYL val, and you set value of YY text. So it is done kind of through some sort of a global variable. So let's actually explore a little bit more. What is YYL val? Yeah, and notice how it has all of the fields of that union that we set in here. Okay, Bison union directive. Declares the collection of data types that semantic values may have. The union declaration. The union declaration specifies the entire collection of possible data values, data types for semantic values. The keyword union is followed by braced code containing the same thing that goes inside the union in C. For example, double val, blah, blah, blah. This way, this says that the two alternative types are double and C. Freaking I know C. They give name of val and tip. These names are used in token and term and type declaration to pick one of the types for terminal and non-terminal symbols. Okay. As an extension to POSIX, a tag is allowed after the... Okay, so whatever. Specifies the tag. Nothing about YYL value thingy. This is not particularly useful. It's kind of funny how they go into detail to explain you the details of the syntax, which you as a C developer should already know, but not any further about this magical global variable YYL val, which is actually important. This is amazing. Just think about it. They go into extended detail to explain you the thing that you already know, but they don't even touch upon the actual important thing. I'm not even mad. I'm really not mad. I'm impressed. This is a next level trolling. This is the next level. People constantly accuse me of rage baiting on Twitter. Motherfuckers, have you read documentation for Bison? You know nothing about rage bait unless you try to read documentation for Bison. It's insane. So, what the fuck is this? This is like straight up insulting. Holy shit. Anyway, I'm gonna pour some water just a second. Oh my god. So, alright. My hypothesis so far is that this thing just like adds fields to that magical variable, which is YYL val and whatnot, right? So, which we can try to do Bison and just Google that specifically. Shut up, shut up. DuckDuckGo developers, please add a button while this motherfucker, while this clanker is generating tokens. Just say, shut up. Don't even generate anything. Just stop. Just add something like that so I can instantly click it. Okay, so token value. Okay, so this one's interesting. Semantic values of tokens in an ordinary non-reentrant parser. Okay, so I suppose it has something to do with. I remember that this term has something to do with multi-threading, right? So just like you can have parsers that are multi-threaded like that, or anyway. The semantic values of the token must be stored into the global variable YYL val. When you're using just one data type for semantic value, YYL has that type, those... Okay. So it refers back to the union declarations. Do they refer to this? They don't even return to this. This page is a little bit more useful, by the way. This page is a little bit more useful. I think I'm getting the gist of this entire stuff, chat. I think I'm getting the gist. So what we have to do is go into Le Parser, and where do we have the unions? Right, so this is going to be union. And in here, we're going to have things like char name. So this is name. So this is how I'm going to call that. And I suppose what we say in here is that this is the name, right? Well, let's call it S value, right? So this is an S value. And so these are semantic values. Now, in LexL, if I encounter ID, YYL val S value, YY text, and I suppose you also have to strdupe it. I kind of remember that being a thing. YY text. So let's find S values. Yeah, so you kind of strdupe it. So they use str copy of. What's the difference between these things? Wait, what? Str copy of? It's not a thing. Is that a thing that is specific to BC? Is that Emacs? Emacs, shut the fuck up, Emacs. What did just happen? Grab this thing. Okay, so it's a custom thing, which is strdupe is an extension of some sort of a standard? Like, why did you implement strdupe? So this is from BC, by the way. So what are the standards? What's a POSIX and GNU? Ah, this one is interesting. So it's not a standard C. Wait, really? To be able to replace Molokov. Okay, that's a good point. Maybe that's the problem in here. But strdupe is a standard thing. Okay, so maybe, all right, that explains it. But in any case, they're doing a strdupe. And we're going to be doing that as well, right? So here is the semantic value. And I suppose this thing exists sort of per token, right? It kind of exists per token, so I can access them differently. And I do quite remember that in here, you were able to do YYL, and it was kind of an array. Oh yeah, so that's the type. And the definition of that type, well, it's not, it's just an integer, but we didn't recompile it yet. Okay, so encounter inside action. Fair enough. All right, so let's go through the warnings. This one is that. All right, any other warnings? It doesn't like, that's understandable, so that is also, okay. Fuck all of the gatekeepers. Fuck all of the gatekeepers. I ungatekeep it. right? So by reading the source code, by trying different examples, by experimenting, I ungatekeep it, I get it, I fucking get it. We cracked it, we motherfucking cracked it, we motherfucking cracked it. I'm in such a good mood right now, in such a good mood, I'm gonna let actually backseaters speak. So you can speak now. Damn, this is trash. It's kind of a, like, honestly, I could have wrote all of that myself. Like, why why exactly do I need Bison and Flex? Why exactly do I need Bison and Flex? I don't quite understand it. So it's kind of weird. It says printf instead of main. It's not supposed to say main. I'm gonna time you out. So it's not even supposed to say main. Okay, so let's actually see. Yeah, so it's supposed to say printf because that's exactly what I'm trying to get in here. So now for backseating, and also for backseating with false information, I'm timing you out for 1 hour. See you on the next stream where you stop doing that. All right. Exactly, you don't need it, you need pack parsers. I haven't explored pack parsers, by the way. I haven't explored pack parsers, so maybe this is some of the things we're going to be doing at some point. Flex and Bison is just a pyramid scheme for gatekeeping Lex and Parser. Yeah, honestly, I think John already talked about it way too many times, but Lex and parsing is kind of like an oversolved problem in a sense. People spend way too much time on it, right? So it's just like it's like overcomplicated, oversolved problem, and it's not even that hard. So implementing all of that stuff without Flex and Bison is not that difficult. It's just not that difficult. Right. Oversolved is everything in that program. Yeah, maybe. And it's kind of weird. So just think about it. Like, so in Alexa, right? In Alexa, what we're doing, we are returning enumerations and also setting global variables that are provided by the parser, and the parser constantly calls a function that is provided by the Alexa. So there is an insanely tight coupling between these two pieces of software, and for some freaking reason, these pieces of software written by completely different people, by completely different projects. It feels like if you wanted to create like a parsing Lexian framework, this should have been a single thing. Should have been just a single integrated thing. Like the fact that they're so tightly integrated and you have all of these magical global variables and stuff like that tells you that architecturally they're trying to stick together architecturally. You can actually feel that. You can actually feel that. I feel like they want you to formalize it by using grammar and shit. Yeah. Do one thing and half-ass it well. All right. That's very funny. That's very funny, good sir. That's very funny. Okay, so I wonder what we can do further. So if this is a fab call, right? So one of the things we can do is just like, yeah, let me see. If this one is strcmp, something like printf, right? Like this. What we want to do is actually literally printf this thing like so. So, and this is going to be 1, 2, 3. So this is what we're doing. Otherwise, we want to kind of throw an error. So we're going to do printf error unknown function as, and as is going to be 1. And here I'm going to abort to do. I can't be asked to learn how to properly do that in Flex Bison. Anyways, so Finally, we could have actually maybe created keywords. So that way it would be super easy for me to have something like this. So this is a return number, right? And here I could have just like return 2 electric boogaloo. So I kind of want to write this interpreter, if you know what I mean. Let's give it a try. I think it's going to be kind of fun. Okay, so if I try to compile, it's probably not going to work, but the compiler assisted refactoring is not going to work with this system well either. Right, so I'll have to carefully go through everything in here. So let's introduce now integers, right? So this is going to be I value, this is I value, and here's the I value like this. And now in Alexa, when I encounter a number, one of the things we have to do in here is YYL value, I value, which is YY text, right? But it's a number, so I probably have to do A to I. So that's what I want to do in here. There we go. The print string exit 69. Yeah. Okay. So I guess that's enough, at least for now. Another interesting thing, strlit. Strlit probably also has to be string value, but from what I saw, by the way, scan L, you can set the tokens like this. So there was a Y, yeah, so tokens. Yeah, so you can specify several tokens in here, so which is kind of convenient in my opinion. So here's the lex, but parse y, here it is. So putting it like that. All of that stuff is more of a punctuation marks. And I wonder if I can actually merge all of them together. Can I just merge all of them together? There we go. So here's the punctuation. So here are integers, here are strings, here's the punctuation. And we also need to introduce return. And I might as well actually call it like this. So this is a return. And in here, return. Yeah, that's kind of funny. So return, and string literal, by the way, is going to be YYL value, S value, str dupe, YY text, like this. Can I just bring all of that stuff a little bit closer like that, and maybe even align returns, and maybe even align open curve? Ooh, that was bad. It's fucking bad. Okay, so this is what we have. This is what we have. Looking good. Looking good. Okay. So what else do we have? If I try to compile the whole thing, is it going to compile? Okay, seems... Did I not forget everything? I think I didn't forget anything. So if I take a look at hello C, so this is hello world, foo bar. To be fair, by default, we also set a new line, so I didn't really have to do it like that. So this is a printf, foo bar, and then here is the return. It sucks that you have to jump between two files to add a new token. Yeah, it kind of sucks, but I feel like you can maybe combine them together. But also, interestingly, BC doesn't combine them together, right? So I don't know. It's a really weird system. It's a and by the way, so if I put 69, just a second, chat, just a second, and I do that, echo, and it returns 69. So this return works correctly. This return works correctly. This thing prints quotes. I don't know why, right? But so yeah, how can we remove quotes? That's very interesting. How can we remove quotes? Do we have strn dupe? Kurwa. Funny. So we need something like str endu. Let me see. So it accepts this kind of stuff. So we're gonna assume that the string literal always starts with a quote, which means that I can do something like +1 and then strlen this -2, or maybe even -1. You see what I'm saying? See what I'm saying? So I just shifted, cutting off the beginning quote, and then I reduce the length by 1 to cut off. Well, I probably have to reduce it. So this is a full length. This has to be -2. Yeah. Yeah. So yeah, I understand. Like, I just fucked up the parentheses. So this doesn't include escaping or anything like that, unfortunately. So honestly, adding escaping through the flex to me so far feels like an unsolved computer science problem. And to be fair, doing that in flex feels like an artificial obstacle. Because when I'm writing lectures, I just have a variable and I'm iterating characters, and I just write an algorithm that switches the state upon encountering opening quote. I switch the state, I consume everything. I encounter escaping, I process in escaping, I encounter closing quote. There you go, I got a string literal. Now I switch from imperative paradigm to declarative paradigm, and a thing that is easy to solve in imperative paradigm, now I have to fight with the declarative one, unless Flex provides an already made solution specifically for escaping in string literals. Unless it already provides that, but I don't know if it does. It does. Okay, so I see. So they already have like a, you know, it's a bunch of pre-cooked meals, like a bunch of recipes, right? But yeah. So anyways, let me see if it actually solves anything, and boom, there we go. Absolute badgering, absolute badgering. That's pretty cool. So what else can we do, chat? Fast food parsing, exactly, fast food parsing. But if it was a real fast food parsing, right? So if I were to implement the fast food parsing system, I would definitely not let it be two separate components that wants to be tightly integrated, but they are actually not. And you have to learn both of them to learn how to tightly integrate them. That's kind of stupid. Right, so if I were to implement the fast food parsing, it would be just one thing. Just one thing, you write all of that in a single file. But I'm not gonna do that, right? So because I think it's easier to just like write Lex and Parser yourself. So, okay, then. Maybe we could introduce some loops. Brother, may I have some loops? How difficult would it be to implement some loops? Because that just means, like, right now, it is rather easy to interpret it. So we are interpreting this thing as we parse it. You see? We're interpreting it as in parse it. But if I introduce some loops, something like repeat 5 times, right? So repeat 5 times. That means that the code that I encounter in here has to be retained. You know what I'm saying? You know what I'm saying? The code must be retained. And that is rather interesting. So, so now we have to have some sort of a AST. AST. How difficult would it be to have some AST? It's an interesting question. Because we're going to be having some AST. We might as well also retain this block. So basically fully parse the body of the function and only then execute that function, then just interpret it. just interpret it. So, and on top of that, you have to have like blocks and stuff. You have to have like blocks. So how much time will it take to implement for me? Because it feels like it's gonna take a little bit of a time to implement that. I'm already kind of running out of time. Do I want to jump into that? Didn't I do that in the BC example in the Parser? This one is rather interesting how they did that in the BC, actually. Statement list. So each individual statement, when they encounter each individual statement, they instantly, the thing they do is actually rather interesting. They generate bytecode. So yeah, they just generate bytecode. They don't really form an AST. They just generate bytecode, and then strategically, they just execute it. So for one instance. So then strategically just execute the code. Interestingly, so you have something like a repeat, right? So repeat 5. And maybe repeat could have been actually a keyword. So repeat, and so lex, not really lex L, but parse Y. So return. Okay, so here I can actually do token repeat. So here we're going to have punctuation marks, and here we have keywords. That's how we're going to be operating in here. So we have different statements in here, right? We have different statements, and the statements are rather peculiar. They are in fact rather peculiar, in a sense that so this you can have a repeat, which is a keyword. Then in the example, you have a number. So this is a number, and then we can have another statement. So we can have another statement. What's interesting is that, can I have associated semantic values for the rules as well? Meaning that if I try to access this rule, this is rather interesting, isn't it? It's with $, so that's what $, means. That's what $, means. It's that semantic thing. So, and through that, you kind of return it, right? So through that, you kind of return it. So this entire thing also means a very interesting stuff, is that if we're going to be having repeat, we should not execute function call. We should not execute function call on as we parse it, which also means that we probably have to execute it in here. Right, so we parse one single statement, and then we have to look at that statement in here, look at that statement, and then switch upon it and execute accordingly. All right, so can we do something interesting? I have an interesting idea. We can have something like STMT, right? So we have a statement, and it's a printf, and another statement, STMT repeat. So this one is more or less statement kind. Let's think of it like this way, statement kind. Then we're going to have a statement, and this is going to be statement kind. That's the kind. And the statement kind, right, it has to be union, right? So it has to be union. So that means you're going to have either a message that you want to print, right? A message that you want to print, or some sort of an other nested statement that you want to repeat, because repeat, it repeats a statement, right? It just repeats a statement. So that means here we're going to have a pointer to the body of the statement, right? Depending on the kind, it's going to be either printf the message or repeat the body several times. So that's kind of the idea. So it means repeat can be also nested. Repeat can be also nested. So all right. So it's more like a linked list, right? So it kind of turns into linked list. And by the way, because of that, we probably have to also do something like that. Right, not necessarily. We can sort of like a forward declare the whole thing. So I'm gonna just grab this kind of stuff. So it's STMT, and this is just that. So yeah, we can self-reference. I found door very. Oh, you're just joking. I thought you're saying something intelligible. Okay, so now what we're gonna be doing in here. So here we don't do anything, and what I'm thinking is that we just like literally have to return maybe a pointer. So let's do STMT printf, where I just provide the message. And in here we're gonna just malloc this entire thing. So STMT malloc size of STMT. This one kind becomes STMT printf. Message becomes message like this. And STMT repeat is rather interesting, by the way. So this has to be more like a count. So count and body, but they are kind of combined together. I don't use union because I just don't want to spend time doing additional definitions and declarations, but just think about these things as unions. One thing we can do, by the way, we can have unions like this. So, right. So see what I'm saying? Is that good? Is that good enough? Right. So we can have it like that. Nice. All right. So and here, so this is a repeat, and we get count and STMT body, right? So that's what we have in here. Count, like how many times, and yeah. So count is the count, and this is the body, right? This is the body. So we repeat that several times. Okay, so let's go through the compilation as STMT printf. This is enumeration, that's fine, and that seems to be compiling. Cool. So the thing I want to do now, excuse me. If I encounter printf, instead of doing that, what I want to do, I want to create STMT printf with a message 3, and I just want to just set it to this thing. Is that what I'm supposed to do? Right? Is that what it's supposed to do? I think that's what it's supposed to do. So in case of the repeat keyword, I just create STMT repeat, and this one is 2, right? So because 1, 2, and then I take a statement which is 3, and that's what I return in here. So we also have another statement that I didn't take into account, which is return, right? So that's one thing we probably have to include in here as well. So this one is return, so comma, and for the return, we're gonna have a code. Right? So all of these structs, they can be factored out into specific types, right? So it's gonna be proper union. I just don't want to do it right now. So what about statement return? Statement return, and this is the code. This is return, and this is the code. Let's go. So what does it say? Doesn't work like that. Statement has no declared type. This one is interesting. So what that's supposed to mean? Oh, statement has no declared type. Interestingly, the union. Yeah, we have to do something about the union, but then, so I know how to associate these things with even this association, I feel like this association is not really that important. Maybe the type thing. Okay, let me see. So type. Ooh, this one's interesting. Oh, and they do have arg list, and it's a pointer. Hell yeah! I think we can work with it. So parse y, and this is gonna be stmt statement value. So a value. Thank you so much. That's the right direction. Okay. Type stmt value. Stmt. Got you. Okay, so this one stmt return 2 like this. And yep. Does it compile? Okay, so there's some stuff in here. So this is, yes, this is what I meant. Another one, semicolon. This motherfucker just compiled. Okay. You know, let's have a function eval statement where I will just take this one and evaluate that. Right, so it doesn't work because we don't have a function in here, but let's implement it. Main.c. Okay. So, well, I mean, to follow the convention, let's call it stmt eval. So this is going to be stmt. All right, so then here, switch stmt. So what's that kind? stmt kind. All right, so. So, and what are we doing here? In case of the printf, that's rather straightforward. So this one is just s with a new line and stmt message. Cool. Now repeat for this less than stmt count, not code but count plus I, recursively stmt eval stmt body. We have recursive definitions, and now return, simply return, actually exit stmt code. Does it compile? Doesn't compile. So so this is a size t. Did I really make it size t? Yeah, I did make it size t. Okay, fascinating. Okay, so implicit declaration of eval, yeah, I changed it. Oh, and by the way, I forgot to return. Oh, right. Completely forgot to return any of these things. Return stmt. It's that one. Return stmt. So return eval, we don't have to really do anything in here. So there's this stuff, which is like it's internal things. I don't really know what it's yapping about. Okay, so it didn't do shit, by the way. I wonder why. Fascinating. So, okay, let's try to debug it. Let's try to debug a wugget. So can we maybe print f d1 more like kind? Obviously, by the way, it leaks memory all over the place, but it's a batch program, so that means it exits, so it doesn't really matter that it leaks a little bit of memory. Okay, so it printed 2 only once, which is rather fascinating. So I was hoping that it is going to like sequentially parse that, give me the full thing, and just execute it. I think stmt gets overridden every time. So it cannot be nested easily like that? Is that what you're saying? That's kind of weird. I thought this, yeah. Yeah, that's why they used that ugly recursion and made a list. Oh my god, really? It's making it difficult than if it would have been if I just did it manually, honestly. So it is easier to do it manually, I'm telling you. So why? Okay, so OPT parameter list, let's take a look at that. So how do you do that? Okay, this one is funny. So this is a parameter list. You initially set it to null, and then inside of the define list, where is the define list? Okay. So they accumulate. Oh my god. They accumulate that into this thing. It's kind of dumb, honestly. It's kind of dumb. Oh boy. All right. So I was hoping that like you encounter that, then you execute that. Maybe it has something to do with like a left associated or not left associated, or some other things. So there's a define list. And next arg. And since this is so unintuitive flow, yeah, exactly. Like it would have been way easier if I just like wrote it in C, right? From scratch. It's not that hard to write this kind of stuff in C from scratch. But yeah, they just make it more complicated than it should have been. So yeah, I suppose if I swap this kind of stuff around, right? Swap this kind of stuff around. This is a statement, so it goes kind of left associated. So that means it's gonna parse it until the end. It's gonna parse it until the end, and then we're gonna have the statements in a reversed order. So I'm gonna actually try to keep the statements simple as of right now. I'm gonna reput the print, right? So I'm just removing the print. And so when I'm executing return, let's not do it like that. Where is my interpreter for this return? So let's not do exit. Let's just do something like exit 69, like this. Not really 69, it's just D, STMT code. That's what I want to do in here. So I just want to try to test some hypothesis in here. If I do it like that, so it's actually 3. Let's not eval it yet. It's a syntax error. It's a syntax error. Syntax error. And when we did that in opposite order, the value that we got in here, stmt list, that value, right? We literally got 2. Wait. This is sus. This is because we get them in a reversed order, literally. Okay, I see it now. I see. So, because it was trying to, yeah, we have to literally. Oh my god, I think I see what needs to be done. This is so stupid, holy fuck, I'm telling you. Alright, so and repeat that 5 times, so it's gonna be now 2, 1, 2. You get them in a reversed order, so you can't execute them in the order as you receive them, so you have to save them somewhere. This is so dumb, holy shit. Okay, so okay, type def struct stmt. Let's get several of them, and it's gonna be stmt items size count capacity. So this is the statements. So this is the parser, and might as well call it maybe statement list. STMTS statement list. Let's call it statement list, right? So statement list, and in BCY union, it's a pointer to arg list, and arg list, I remember it was the what it was. It was a linked list, so because of that, doing that in reverse order was kind of fine, I suppose. Yes, it was kind of fine. So in here, do I want to do it as a pointer? I want to actually store it as a value. So stmt list value. So that's what we're going to have in here. I wonder if it's going to work. So stmt list value stmts. Actually, I already yeah. So it's already stmt list. Right, so this is a stmt list, and in here what we're going to be doing is di append yy, and it's not a pointer, so that means I have to take a pointer to this thing. I have to take a pointer to this thing, and then I'm going to be appending this stuff like so. So then in here, 1, 2, 3, 4, 5, 6. At 6, I can iterate that main, and let me put ZU in here. And I'm gonna take 6, and it's gonna be a count. Just want to see how many of them I have in there. All right, let's go through compilation as semicolon. Understandable. Oh, that's it. Okay. 1. This is not correct. Does it have to be a pointer though? Counter imperative program. Yeah. So it's like I want to do imperative stuff, but it just doesn't allow me to do that easily. So the problem here, chat, is that I'm not quite sure. In BCY, arg list, what is the arg list? It is a pointer. They literally do that through linked list. I swear to God. It is so dumb. I just can't express how fucking dumb it is. Right, so they do that through linked list. And it feels like we have to do it similarly. Right, we must do that similarly. I'm not sure why my dynamic array idea doesn't work. Is it because it's also being overwritten? Because it should kind of work. It should kind of work. So I can also print stmt list, and every time we print this entire thing, I should be able to just do count and just see if it grows or not. Does it grow? So make b, now let's go. It never grows. It does it just create? Okay. All right, so okay, let's do it something like that. So can I just do starting from body count while I is greater than 0? minus I, and stmt eval value items I minus 1. All right. So let's put 3 in here. Right. Okay, that's very interesting. Now I can try to repeat it 3 by 3, 9. 3, 3, 3. So we even have a nested repeat in here. Look at that. You can nest them together. I hate it. I hate Flex and I hate Bison, and I only would work with it if you pay a shit ton of money. I haven't seen you this pissed off. I'm not really that pissed off. I mean, I understand what this thing is about. I can achieve some things if I need to, but holy shit, I would never do that recreationally. Again, if you want me to work with Bison and Flex, pay shit ton of money to me. Like, you have to pay a lot to, like, to force me to work on this stuff. This is garbage. This is straight up garbage. Like, all of this stuff is just easier to write yourself. Like, Lexer is not that difficult to write. Parsing this simple grammar is not that difficult to parse. Like, this is, maybe you may say that it is an overkill for this kind of stuff. But a lot of people who write complicated languages also say that Bison and Flex is insufferable. I think its only use is in academia. Maybe, yeah. So again, Jai doesn't use any of the Flex or Bison. A lot of modern languages, by the way, don't use any Flex and Bison. There's like nobody fucking uses it. So yeah, it's kind of like an academic masturbation tool. An academic masturbation tool. Well, I got a gist of it, right? So I achieved what I wanted to achieve. And yeah, so I spent 3 hours debugging. And it was a single missing semicolon. So was it fun, chat? What do you think? What do you think about this tool? Is it fun? Nobody uses Yak nowadays either. Yeah. So the time you take to learn this, you can also learn writing a parser. Yeah, exactly. So I think one argument that I heard about using this sort of like a parser generators and stuff like that is that they generate like a state machine, a very efficient state machine, which is faster than, you know, using recursive descent, right? So that's one argument that I heard. But I think this argument is coming from the times when we programmed on machines where function call was extremely expensive, right? You guys remember those times, right? So 70s. I wasn't born there yet, but I heard, right, so that on old machines in 70s, it was very expensive to call function, and because of that, it was better to just generate a finite state machine to process this entire stuff. And another argument that I heard for using this kind of parser generators is that it generates the parsers that can stop parsing in the middle of the source code. So sometimes, like, you want to parse it, stop in the middle of parsing, do something else, and resume parsing. And this kind of stuff is useful primarily, I think, for auto-completion and stuff like that. Does Bison and Yak, generate this kind of parsers where you can just like stop, save the state of the parser, and then resume it again? Now, couldn't you write a state machine also by yourself? It's kind of tedious. We can take a look. We can take a look at what exactly it generates. So tab.c. So let's find some stuff. For example, da append. So as you can see, this is the kind of stuff it generates. So YYN, I presume, is the current state of the state machine, and each individual case is the I suppose rule. They even put that in the comments. Look at that. They even put that in the comments. Yeah, it's kind of fun. So, in statement value, we save a statement value, right? And here is the huge switch case for the state machine. So then at the end, how do they process YYN? That's kind of interesting question. Yeah, I suppose this is the table, right? So that's the switch table. Do they assign YYN? Yeah. Yeah, it's kind of fun. Right, so here's the YY state, and so this is the kind of stuff that you want to write yourself manually. You probably don't want to write it yourself manually. Pop stack until we find a state that shifts the error token. Yeah, so it's literally they're compiling it to a virtual state machine. They're compiling it down to a virtual state machine, and then this parser basically interprets that, you know, state machine. So that's what they do. All right, so that was an interesting exploration. I guess that's it for today. Thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you all on the next recreation programming session with a Mr. as always, and I love you all.